All right, hey AP Chemistry. I want to do another example from your homework related to using standard enthalpies of formation to calculate the enthalpy of reaction. This is a little bit more plug and chug, and I know a lot of us are strong with that and like just plugging in numbers. So let me just read the example and walk you through. So it says pentane, which is C5H12, is a component of gasoline that burns according to the following balance equation. And they give you this. C5H12 liquid plus 8O2 gas yields 5 CO2 gas plus 6 H2O gas. And this, remember, is a combustion reaction. If we did the Cheeto lab, when you burn something in air, you get CO2 in water. That's a combustion reaction. And now I have this reaction, didn't give me a delta H. It says calculate the delta H of reaction for this reaction using standard enthalpies of formation. And then it also said the standard enthalpy of formation of liquid pentane is negative 146.8 kilojoules per mole. Now, I wrote this information here in blue, but this stuff is in the back of your textbook. It's in Appendix 2B, page A-5, but it's at the very far back where it's after pages 1165. So basically there's this table, and it's a table of delta H's, something known as delta S, and something known as delta G, and it gives you all of the delta H's of formations. So if you look here, and we'll talk more about this in class and in notes, the delta H of formation of CO2 gas, if I look in this appendix, is negative 393.5. Delta H of formation of H2O gas is negative 241.8. Delta H of formation of oxygen gas is 0, and that's going to be true for any element in its standard state. Delta H of formation is going to be 0. And the delta H of formation of C5H12 was given in the problem. Okay, so this is all stuff you look up or are given. On the AP exam, you're given this. Like, it'll be a problem, and it'll be like, here are some standard delta H's of formations, now solve for this. Now, how do I use these? There's an equation. Delta H of reaction is equal to the sum of N times the delta H of formation of the products minus the sum of N times the delta H of formation of the reactants. Now, this is an equation that's given to you on the AP exam. It'll be given to you. You don't really have to memorize it. But what this means is if I have all of the delta H's of formations of each of the products and I multiply times the moles of the products and add those together, if I subtract it from all of the delta H's of formations of the reactants multiplied by the moles of each of the reactants, I will get the overall delta H of reaction. This comes from Hess's law, where it doesn't matter where or what the reaction did, all of the steps adding up to the overall reaction will give you the delta H of reaction. So let me show you that calculation with this equation. I'm going to set this up. So if I want the delta H of reaction, and it's products minus reactant, my products, I have 5 CO2s and 6 H2Os. So it's going to be equal to 5 times the delta H of formation of CO2 plus 6 times the delta H of formation of H2O. And I'm going to subtract that, right? These are the products. And the 5 is the N. N is moles, right? This is for every mole of CO2, and I have 5 CO2s. That's why I'm multiplying by moles. Minus C5H12, the delta H of formation of that, and there's only one of them. The delta H of formation of C5H12, and there's only one of them. Plus, now I'm not going to write it in, but it's going to be plus 8 times the delta H of formation of O2, which is 0. And now I'm going to plug and chug these numbers in. I'm going to do 5 times delta H of formation of CO2 is negative 393.5 kilojoules per mole. Plus 6 times delta H of water is negative 241.8 kilojoules per mole. Minus, and it's just one of these, the delta H of formation of 146.8. And I'm not going to write in the oxygen, because it's just 8 times 0 kilojoules per mole, which is 0. So that just cancels out. And so I'm just going to do minus this number, minus negative 146.8 kilojoules per mole. The biggest thing that messes up students in AP chemistry is your minus signs and plus signs, and if you multiply by a minus and so on and so forth, and changing the sign. So now let's plug on all these numbers in. 5 times this number. All right, so I'm going to do 5 times negative 393.5, and I get negative 1967.5. Negative 1967.5 kilojoules per mole of reaction. Plus, I'm going to do 6 times this. 6 times negative 241.8. So I'm going to get plus negative 145.8 kilojoules per mole. Minus negative 146.8 kilojoules per mole. And now be careful here. If I have minus a negative, it just becomes plus. So this becomes plus positive 146.8 kilojoules per mole. And I'm going to put these two numbers together. Both of these are negative. If you add two negative numbers together, you should get a bigger negative number. So I'm going to have negative 1967.5 plus negative 1450.8. I'm just adding these two negative numbers together, and I get a bigger negative number. So I get negative 3418.3. Negative 3418.3 kilojoules per mole. And now all I got to do is put these two numbers together. So I add this to 146.8, and I get, right, so I just take that number, add it to 146.8, and I get negative 3271.5, which is the delta H of reaction. So delta H of reaction is equal to negative 3271.5 kilojoules per mole of reaction. And that is our answer. That's all you do. You plug and chug. You get the numbers or are given the numbers and then plug and chug into this equation. Delta H of reaction is the sum of all of the delta H's of formation of the products minus the sum of all the delta H of formation of the reactants. Sometimes on the AP exam, they'll give you a delta H of reaction and you'll have to find one of the elements or compounds in the reaction. So it's kind of like just solving for X. Sometimes, like, the other way this could have been given is if I told you the delta H of reaction was equal to negative 3271.5 kilojoules, and I want the delta H of formation of C5H12 liquid, right? So this would have been your X in that case if I wanted to do that. So I'd already have my delta H of reaction. I'd put all these together and I get plus X, and then I would just solve for X and I would get my answer. So you'll see questions like that in the beginning where, okay, what if I know the delta H of reaction and I'm looking for one of my elements and compounds? You just plug it in as though it's X. It's kind of like if I want my final temperature with Q equals MC delta T and I already have the Q, I would set T final as being X. Okay, and then just to quickly show it over about delta H of formation, I'm just going to do one or two of them. Now, delta H of formation is the energy required to form that reactant, that specific compound. So, for example, NO2, the way that you write an equation for a formation is any of the elements that are in the compound, you write them in their standard states. So, nitrogen, remember Hofbrinkel is very important for this, and this will show up in our notes again. I got N2 gas plus O2 gas yields NO2 gas. And now, again, standard H's of formations are those weird equations where I could have half coefficients. So I have two oxygens, but only one nitrogen in my product. So I should have 1/2 N2. And then the delta H of formation is going to be in Appendix 2B. I'm not going to put the answer. I just want you to get practice in finding it. Right, so I just look up the delta H of formation of NO2 gas in Appendix 2B. These are going to be 0. Prove to yourself that delta H of formation of O2 is 0 kilojoules per mole. And the delta H of formation of N2 is going to be 0 kilojoules per mole. The delta H of formation of elements in their standard states are 0. So you're just looking up for this compound in the back of the text, and then boom, you're done. You have the rest of your answer. I'll do letter B. So there's 3 elements in here. Magnesium is a solid. Magnesium is a metal solid. Carbon exists as a solid. And then oxygen is O2, diatomic element, MgCO3 solid. Oxygen is in Hofbrinkel. Even though there's 3 oxygens here, we write elements in their standard states and put them together, so I didn't even do anything, and then I balance. So if I have 3 oxygens here and 2 here, I could do a weird fraction where it's 3 halves. Right? This 3 halves cancels out to just 3O, and if I want the delta H of formation, you look up in Appendix 2B. And again, the delta H of formation of elements in their standard states, magnesium, carbon, oxygen, they're going to be 0. And then I'll just do one more. C2H4 will just be carbon, plus remember Hofbrinkel, H2 gas, yields C2H4 gas. And then to balance, 2 C's, 2 H2s, and I get C2H4. Now, again, elements in their standard states are going to be 0 kilojoules per mole. And then I just look up if I want the delta H of formation of C2H4. I'm just going to look that up in Appendix 2B. Okay? Alrighty, so in this video, I walked us through how to calculate delta H of reaction using standard enthalpies of formation, and then I just quickly showed you how to write standard enthalpies of formation. So use this video to help you get a good majority of your homework accomplished.